Assalamu alaikum. Today, inshallah, we will take the first lesson in the second term, metals and nonmetals. That we have already idea about it from the first term, but today we will continue taking more difference points between them. So that in this lesson we have 3 points to study. The first one is the difference between metals and nonmetals. Second, metallic bond. And the third point about the alloys. So let's say Bismillah and start the first point. Difference between metals and nonmetals. Let me start with a question. If I give you different elements and I ask you which one of them is metal, how will you identify the type of the element? I don't have to memorize what are the metals and what are the non-metals because simply if you remember, we can know the type of element from its electronic configuration. So for example, I want to know the type of sodium element. So that first I have to draw the electronic configuration by the number of electrons here. So first level K will take 2 electrons. Good. Second level, 8 electrons. Still have 1. So third level, take 1 electron. So again, now how many electrons in the outermost energy level? It's 1. And we said if we have 1 or 2 or 3 electrons in the outermost energy level, what will be the type of the element? Good. Metal. Metal. So just from configuration, I could know the type of the element that I have. Let's do the same for chlorine. First level, take 2. By the way, I have 17 electrons here. Second level, 8. Third level, 7. Now I finished the 17 electrons. So how many electrons in the outermost energy level? We said if we have 5 or 6 or 7, so what will be the type of the element? Good. Non-metal. Non-metal. So actually this is the first point in the difference between metal and non-metal, that the electronic configuration of metal ends with 1 or 2 or 3 electrons. Like here in potassium, just care about the last one. I don't care about the first level or this one or this one, just the outermost one. How many electrons here? Only 1. So you are metal. Look about this one. Non-metal, the electronic configuration ends with 5 or 6 or 7. So look here for nitrogen. I don't care about this level. I just care about the last one, the outer one. So how many electrons here? 1, 2, 3, 4, 5. So of course you are non-metal. This is the first point. Second point, about conductivity. And here I mean electric and heat conductivity. So for example, if I added a kind of metal here, will the electricity pass through the whole circuit and also through the metal reaching to the end of the circle? Can the metal allow electricity to pass through it? Yes. For metals, they are good conductor of electricity and also for heat. For example, if I have this is a piece of metal, if this end of the piece of metal is heated up, the rest of the metal will be hot. Why? Because heat can pass through it. So metals are good conductor of heat and good conductor of electricity, which means it allows electricity and heat to pass through it. While non-metal, it's bad. Bad at everything. Bad conductor for heat and bad conductor for electricity, which means if I added here non-metal, it will not allow electricity to pass through it. Never. The same here will not allow heat to pass through it, except, and take care about this exception, graphite element, which means carbon. This is the only good conductor non-metal for electricity. Take care, please. This is important note because it comes many times in different types of question. Include complete, correct, and even give reason. So take care about it, please. So all non-metals are bad except only one non-metal which is good at electricity conductivity, which is graphite element. Graphite element. Good. Point number 3, about the physical state. When I say physical state, I mean if it's solid or liquid or even gas. So look here, for metals, all of them are solids. All of them are solids like this, except only one metal which is liquid. Mercury, look here, seems like liquid, seems like water. That is why it's liquid element. Only mercury. For non-metal, although only one liquid here, bromine, while the rest of non-metals are solid and also gas. Take care, solid and also gas, except one liquid, which is bromine. Bromine. So here I have, if you noted, only 2 liquids for the whole metal or non-metal. Mercury and bromine. Mercury, which is metal, bromine, which is non-metal. Take care in the question when he asks you to give an example of liquid element. If he said, give me an example of liquid element, you can say mercury or bromine, it's up to you. But if he mentioned, give me an example of liquid metal, so here I have to write mercury. I have to take care about what is the ask of the question. Take care about this, please. Point number 4, about melting point. What's meant by melting point? Melting point means the temperature at which the solid matter turns into liquid. Solid turns into liquid. So metals, do they have a high melting point or low melting point? Or by another way, if I want to convert a solid metal into liquid, do you have to use too much amount of heat or just a little amount of heat is enough? Actually, for metals, it's high. You have to use too much amount of heat if you want to melt it. So that's why, if you noted, all cooking utensils are made up of metals, a kind of metals. So if I left this cooking pot on this flame for an hour, 3 hours, for a day even, it will never melt. I will cook and it will never melt because again, it's metal and it has high melting point. For non-metal, it is just vice versa. The melting point is low. Just a little amount of heat is enough to convert it from solid state into liquid state. You have to know the examples. It comes in complete question or even correct. So here, metals like sodium, copper, zinc, silver, and iron. Non-metals like carbon, sulfur, phosphorus, bromine, and iodine. Good. Point number 5 and the last one. About the shape of the metals. They are malleable and ductile. What does it mean? It means that you can have different forms from it. Look here, I'm using the hammer on a gold piece and it will never broken down. It just give me different shape so that I can have many accessories from gold because it's formable. I can have different forms from it. That's because again, it's malleable and ductile. And also, metals have metallic luster, which means it's shiny. Look at this piece and even look at this. It's very shiny. So it's bright. Metals have luster. They are shiny. Non-metal are just vice versa. Not malleable, not ductile, not have metallic cluster. That is all. So look here, if I have a piece of sulfur, it's a kind of non-metal, and I try to use hammer, it will never give me different forms. Just broken like this, giving me different or many small fragments, many small pieces of it. It's broken, not having different forms like gold. So it is not malleable, not ductile. And look also here for this cool piece. Is it shiny like gold? Of course not. So it's not having luster, not shiny, not bright. Clear? Now let's summarize all this difference point here. About configuration, how can I know them? Metals have 1 or 2 or 3 electrons in the outermost energy level. Non-metal have 5, 6, or 7 electrons in the outermost energy level. About conductivity, they are good at everything, but non-metals are bad, except, and take care again, except graphite, the only good conductor of electricity. About physical state, they are solid, except one liquid, which is mercury. And here also solid, in addition to gases, except one liquid. About metallic point, or even the shape, it's just like the conductivity. These 3 points of this, if you noted, are just the opposite in metals and non-metals. So, for example, conductivity in metals are good, in non-metals, just bad. Metallic point in metals, they are high. In non-metals, it's low. The shape in metals, malleable and ductile. Non-metals, not malleable or ductile. Shape in metals have metallic luster. In non-metals, doesn't have metallic luster. Let's see a type of a question which care about the shape point. He can ask you in a give reason. A piece of gold can be easily shaped in various forms, can have different forms at all. So once you ask me about the shape, you have to think directly about the point of shape. So if it has different forms, it means it's metal, it means it's ductile and malleable. That is all. Let's see another give reason. Graphite is used in the manufacture of dry cells, although it's non-metal. Why he said although? Because we know that non-metals are bad conductor of electricity. So how can we use graphite, or as I mentioned, it's also carbon, how can I use it in an electric circuit if it will not allow electricity to pass through it? Oh, remember, we said graphite is the only non-metal that is good conductor of electricity. So, because graphite is good conductor of electricity. Here we finished the first point. I hope you understood it very well. And if you have a question on it, you can write it in a comment. Let's go to the second point. Metallic bond. When I say metallic bond, from its name, metallic. So do you think it comes from metal or non-metal? That's it, good. Of course, metals. Metallic bond, it's about metals. So that I have to remember with you what exactly is metal. We mentioned I can easily know it from its electronic configuration because metal have 1 or 2 or 3 electrons in the outermost energy level. Just like sodium that we draw before. It's 2, 8, 1. So 1 means I have metal. Let me ask you a question if you remember. This number, show me the number of what? I know it's atomic number, but this atomic number mean this is the number of what? Yes, it is the number of protons which at the same time, it also the number of electrons. Because if you remember, we know that number of protons equals to the number of electrons for the atom. So here it means that I have number of positive charges, because protons are positive, equal to the number of negative charges. So the total atom now is neutrally charges. Do you remember that? So protons positive, electrons negative, and both of them are equal. Both of them are 11. So I have number of positive equal to number of negative. So my atom is neutral atom. Another thing we have to remember, we said for this metal which have one or two or three electron, or even for non-metal, any element will tend to go into a chemical reaction in order to have how many electron in the outermost energy level? 8 electrons. Any elements wants to have 8 electrons in the outermost energy level in order to be very stable, very relaxed. So here, is it 8 in the last level? No. So of course it will go into a chemical reaction in order to be 8. And in order to be 8, we have two options. Maybe lose this one electron, lose this one electron. So now the last one will be 8 after losing this one, or gain 7 electron above this one, so it will be 8. What is easier? Lose just one or gain 7 electron, 1, 2, 3, 4, and so on, till 7 electrons to be 8. Of course, losing one is easier, so that if you remember also, we said if I have metal, metals tend to lose electron. So actually, this sodium element will lose this one having 2, 8 only. Now it's very stable element because it have complete number of electron, which is 8 in the outermost energy level. The question here, do I still have number of protons equal 11? Yes, because I didn't play with protons. I didn't lose or gain protons. But I lost one from electrons. So number of electrons now, not 11, they are 10, which means number of positive charges are now greater than number of negative charges. Do I still have neutral atom? No, because they are not equal. Positive is more. So now the atom is positively charged, and now it's not atom, it's ion. I have positive ion. Why do I have to remember all of this? Because that's exactly what happened inside any kind of metal. Any metal has inside it many atoms, and each atom of them can lose the last electrons or the electron of the outermost energy level. They are free electron. So we said now electron is negative, and now the ion itself is positive. Positive and negative make attraction or repulsion. Good. Attraction. Opposite charges make attraction. So inside this metal piece, I have many of these positive ions and free valence electron. The attraction between them is the metallic bond. Or this is the reason why I have this piece of solid like this, because If it's negative, so it means it attracts the positive ion. And here this negative attracts the positive ion. And here this negative attracts the positive ion. So makes all ions attracted to each other, giving us this peace. So that's why it's called metallic bond, because it exists only in metals, because only metals can lose their valence electron or their outermost electrons. Well, I have this bond in nonmetal. How come? Nonmetal don't lose. They just gain. So you don't have free electrons. So you don't have attraction. So you don't have metallic bond in nonmetals. Another thing you have to know, this piece of metal has many ions arranged or many atoms arranged in a very ordered shape like this called crystal lattice. Again, the atoms of the metal are gathered and arranged in a very ordered shape called crystal lattice. Positive beside negative, positive beside negative, and so on, and positive beside positive, and all atoms beside each other in a very organized or ordered shape again called the crystal lattice. Where cations, here cations means the positive ion, surrounded by a cloud of free moving valence electron, which is negatively charged. That's why we have attraction here. Finished. So all what I have to know about metallic bond is the definition. It's the attraction between positive ion and the negative free or the negative valence electrons. And also have to know that metals are crystal lattice in their shape. Take care about this note, please. Look here. I mentioned now that these atoms of the metals are attracted to each other because of the valence electron. So the question here, if I have different types of metals, sodium, which each atom of them give only one electron, magnesium, each atom of them give 2 electrons, aluminum, each atom of them gives 3 electrons. Why? If you want to know why, you have to remember the configuration of each one of them. And here I give you their samples. So the question here, by increasing the number of electron or the number of valence electron that can be lost from one atom, will this attend to increasing the metallic bond? You have to ask yourself a question. These electrons leads to increasing the attraction between ions? Of course, yes, because electron is the reason why ions attracted. So if I have more electrons, it means more attraction, and so the metallic bond strength will be stronger or is higher, or it increases more and more by increasing the valence electron. And of course, now I have harder metal. Harder metals means what? Means if you want to turn this metal into solid, I mean melting, from solid into liquid, I mean melting. So will you have to use too much heat or less amount of heat? Increasing valence electrons make my metal harder. So of course, I need more amount of heat to let them be away from each other, to let them convert into liquid, because melting means that the metals or the metal atoms get away from each other. So I need more heat because the attraction here is too much. So I need too much heat to let them be away from each other. And that is why melting now is higher melting point. Clear? Here we finished the second point, metallic bond. I wish you understood it. Let's go to the last one, alloys.